Did you know the chemistry we study today, reactions, experiments, laboratories, can be traced back to a Muslim scientist who lived more than 1,200 years ago? His name was Jabir ibn Hayyan. He is known as one of the earliest pioneers of chemistry, not just a theorist, but a true experimental scientist. His full name was Abu Musa Jabir ibn Hayyan ibn Abdullah al-Azdi. The title al-Azdi was given to him because he came from a major tribe in Yemen, the Azad tribe. Jabir was born in the year 101 Hijri, or around 720 CE, in the city of Tus, Persia, a region that is now part of modern-day Iran. His father was a pharmacist. From a young age, Jabir was already familiar with the world of remedies, substances, and natural chemical materials. Jabir later settled in Baghdad, the center of world civilization at that time. There, he formed close ties with a powerful Persian noble family, the Barmakid family. One of its most prominent figures was Ja'far ibn Yahya al-Barmaki. Jabir's relationship with Ja'far grew stronger until he was eventually introduced to the great Abbasid Caliph, Harun al-Rashid. In the presence of the Caliph, Jabir presented a remarkably bold idea. He proposed that Greek scientific books be brought from Constantinople, so that the world's knowledge could be studied and developed in Baghdad. A grand vision, a first step towards the golden age of Islamic science. Jabir ibn Hayyan's journey in knowledge began with religious studies. He studied under Harb al-Hamiri, but the most influential figure in his life was a great scholar, Ja'far as-Sadiq. Under the guidance of Imam Ja'far, Jabir did not only study jurisprudence and theology, but also philosophy, logic, and the hidden secrets of nature. It was here that the foundation of his scientific thinking was formed. He later became interested in Sufism and philosophy, seeking meaning beyond the material world. Imagine, in the 8th century, he had already opened himself to literature from different civilizations. He did not limit knowledge to one nation, he saw it as belonging to all humanity. Before Jabir's time, what was called chemistry was still a collection of primitive practices. In ancient Egypt, this knowledge was used to preserve corpses, to tan leather, and to produce glass, dyes, metals, perfumes, and oils. Some people even used it to try to transform cheap metals into gold. This practice became known as alchemy, a mixture of experimentation and myth, a mixture of knowledge and magic. Many believe that turning iron into gold was possible, if only one could find the elixir, a magical substance that could transform anything. And yes, Jabir was also fascinated by the secret of this elixir, but unlike others, he did not search for it with spells. He searched for it through experiments. From this point on, alchemy slowly transformed into chemistry, from a secretive practice into a structured discipline. Jabir laid down its foundations. He introduced new theories. He explained chemical processes in a systematic way. It is no wonder that many historians refer to him as the master of chemistry. One of Jabir's most important discoveries was his success in combining hydrochloric acids and nitric acid. This mixture later became known as aqua regia. literally meaning royal water. It was given this name because of its ability to dissolve gold, a metal that had previously been considered almost impossible to destroy. Jabir referred to these strong acidic substances as corrosive waters because of their power to dissolve metals. Jabir was able to distinguish between acids and alkalis, a fundamental concept in modern chemistry. He explained that these two substances could react with one another to produce salts, a concept that is now taught in schools all around the world, was already understood by him more than 1,000 years ago. He also identified various organic acids such as citric acid, tartaric acids, and others. He did not merely recognize them, he studied their properties and reactions in detail. Jabir carried out numerous important experiments. He processed burnt soda to produce sodium hydroxide and sodium carbonate. He combined silver nitrate with tin carbonate. He separated arsenic from arsenic sulfide. He isolated antimony from its compounds. He was even able to distinguish between true dissolutions, when a substance completely integrates into a liquid, and a suspension, when particles are only dispersed and can later be separated through filtrations. Jabir also discussed methods for purifying gold from its raw materials, as well as its relationship with gemstones. He did not create gold from cheap metals. He purified gold from its impurities. Jabir developed effective methods for purifying metals. He studied how steel could be mixed with specific compositions to make it stronger for industrial use. Beyond that, he also formulated ways to protect iron from rust. At a time when weapons, agricultural tools, and construction all depended on metal, these discoveries had a profound impact. In that era, gold ink was a symbol of luxury. It was used to write important manuscripts, sacred texts, and royal documents. But gold was expensive. Jabir later devised a method to produce ink from iron sulfate mixed with gold, as a more efficient alternative to using pure liquid gold. Jabir's discoveries also touched the everyday lives of ordinary people. He developed techniques for dyeing leather, processing and strengthening woven fabrics, creating coatings and pigments, and even dyeing hair. Things that may seem simple today, but in his time, they were remarkable technological innovations. For Jabir, experimentation was the heart of knowledge. He once advised his students, "The first duty is to conduct experiments. Whoever works without experimentation will never truly master their science." Jabir also stressed the importance of careful and consistent observations. He told his students, "Scientists do not take pride in the number of medicines they possess, but in the quality of their supervision and observations." It is true that the newly developed scientific method emerged several centuries later through great scholars, such as Ibnu al-Haytham and al-Biruni. But Jabir had already laid its foundations. He spread the principle that knowledge must be tested, that ideas must be proven, and that experimentation is the path to truth. Jabir also held profound views on education. He advised teachers, "The duty of a teacher is to examine the student on the essence of the knowledge being studied. If the student is capable, then guide him according to his ability and age. And when a student has reached the level of a teacher, he becomes obligated to teach, because knowledge is not meant to be kept, it is meant to be passed on. The students, Jabir said, the duty of a student is to be gentle toward his teacher, to accept his words in the knowledge being studied, and not to oppose him in that matter. However, he also clarified that this obedience applies only within the scope of knowledge being taught, not in every aspect of life. Some of Jabir's most well-known written works include Al-Khawas Al-Kabir, one of his most famous books with a surviving manuscript preserved in the British Museum, Kitab Al-Sab'in and Kitab Al-Rahmah, which were later translated into Latin during the Middle Age, Al-Jumal Al-Ishrun, a collection of 20 treatises on chemistry, Al-Ahjar, whose manuscript is preserved in the National Library of Paris, as well as Asrar Al-Kimiyya, The Secrets of Alchemy, and Usul Al-Kimiyya, The Foundations of Alchemy. More than 1,000 years ago, a Muslim scientist transformed the way humanity understood the world. In a modest laboratory, Jabir ibn Hayyan proved that knowledge is not born from guesswork, but from experimentation. He transformed alchemy into chemistry. He laid the groundwork for the scientific method, and his legacy is still studied to this day. If this story inspired you, don't let it stop here. Press like and leave a comment. Share this video and subscribe for more stories about the golden age of Islam that changed the world.